Before we go any further, before we learn how to do the last type of basic sailing, we need to understand what meridional parts are. This is the solution to the problem we've been dealing with. We've been dealing with how to properly compensate for the curvature of the Earth during a sailing. For a plain sailing, we just ignored it. For a parallel sailing, we just chose a situation where it wasn't relevant. For a mid-latitude sailing, we took an average of the two latitudes and acted off of that principle. Now we're actually going to find a way to account for it accurately. Now, meridional parts, the way they work is somebody much smarter than me sat down and calculated the exact slope of the curvature of the Earth. So we already spoke about how the Earth, this is just half of it, how the Earth is an oblate spheroid. It's not a perfect sphere like I'm trying to make there. It's not perfectly round. It's wide at the equator and then squished at the poles. I forget, it might have been Mercator himself, the guy that the charts are named after. It might be someone else, I forget. But a mathematician sat down and calculated what this change in slope actually is, and then created a formula to account for it so that you can always accurately know what this angle difference is going to be between any 2 points of latitude. That way, when you were to go into a sailing, you could actually accurately account for it. Now, instead of using that formula, because I'm not going to make you learn another formula, our number one book, Bowditch, placed an entire table, an entire section of the book dedicated to taking that formula and quantifying it out into one large table. So you could always just reference any two latitudes and find what its meridional parts would be. Meridional parts being the name for this change in slope right here. Just give me a moment to move this out of the way. And this is what it looks like. Table 6. On my copy of Bowditch, it is on page, can't really see, but it's on page 667. That might be different depending on what edition and what version you have, but it's probably always going to be table number 6. It's also in the table of contents, within the tables page, but the one that you're going to use without a doubt the most, if not exclusively. If this doesn't look that horrible, it's because you don't know that it actually goes on for another 4 pages of just meridional parts in all of this. That's because it spells out every possible degree value. You can see, if we go back to the front here, if I zoom in a bit, the way this table is broken down is you have your degrees listed on the top as the columns, and then your minutes listed along the sides from 0 to 60. So for instance, this one right here, if you go up, you can see it's on the 5 degrees column, and if you go across, it's on the 14-minute row. So that is the meridional parts for 5 degrees, 14 minutes. And the way you read it is it's not 12.3. Every single one of these little boxes just kind of drops the highest number because they want to save ink. So in this box, they dropped the 3, and you can just imagine that there's a 3 in front of each of these. So in this case, 5 degrees, 14 minutes is 312.3 meridional parts. If we come down to this one, right there, move up to the column, you see it's the 7 degrees column. Come down, okay, 7 degrees. If we come across, 37 minutes. So this is the value for 7 degrees 37 minutes, and you can see it is 455.3. Let's skip a couple pages. So the high numbers come up here. See, now we're in the 60s. And that one. Right there. You can tell that it would be read as 4930.6, so 4,930.9 meridional parts. And it is the meridional parts value for 63 degrees, 21 minutes north or south. This can be used north or south. And in case you were wondering, minutes are shown on the other side as well, just so you can find it more easily. In this case here, you can see that they kept the leading two numbers through multiple. That's just because we were transitioning from 47,000 to 48,000, so they wanted to be more precise. But in most other situations, they drop them off just so that they don't have to type out as much, and it's easier to kind of read and get your bearings on. The way you use this is in the last type of sailing, which is called a Mercator sailing. Let's imagine you had 2 points you were trying to get to, obviously, or get from one point to another. And let's ignore the latitude for now because the latitude doesn't matter. The longitude doesn't matter. Let's ignore the longitude. And let's say your 2 points were 20 degrees 32 minutes north and 7 degrees 49 minutes north. What the formula would be asking for is little m, which is equal to the difference of meridional parts. It's almost always written little m. If you want to, you could do dm for difference of meridional parts if that makes it easier for you, but every textbook is going to write it as just little m. So what you would do is, as we just proved, every single value of latitude has a corresponding meridional parts value. So you would take these two values, 20 degrees 32, 7 degrees 49, and you would go into the book and you would find their corresponding values. So we'll start with 20 degrees 32. Open up Bowditch. Here's the section that is devoted to 20 to 30. So we go to a 20 degree column and we follow the rows down till we get to 32 right there. 51.2, you bring down the leading two numbers. So 20 degrees 32 is 1,251.2 meridional parts. 1,251.2 meridional parts. Now we need to find 7 degrees 49 minutes. So we go back to our table, bring it down to the beginning section. There's our 7 degrees column. We follow our rows down further to 49. So 7, 49. Actually, because it's such a pain to come all the way from the top there, you can go from the bottom as well. 7 up to 49. Get across 67. Bring down the leading number, 467.3. $467.3. So these are your two meridional parts values. 1251.2 corresponds to 20 degrees 32 minutes north. 749 degrees north corresponds to 467.3. So now, your difference of meridional parts, you just subtract the two. And just like with difference of latitude, difference of longitude, it's not directional. You don't care if you're going north or south. I did those opposite, north or south. You just need the full sum value with no sign attached. So you do 1251.2 minus 467.3. $1251.2 minus 467.3. You get 783.9 as your M value, or DM if you prefer. That is your difference of meridional parts. That is what you will use for these equations moving on. Now, as an important note, what if this wasn't 7 degrees 49 minutes north? What if this is 7 degrees 49 minutes south? You do exactly as you would with latitude. This is just latitude converted into some different terms with a different formula, like impacting them in one way or another. So if it's now north and south instead of north and north, instead of subtracting the two, I'll just write, well, I won't. Instead of subtracting the two, you would add them. So in that case, your difference of meridional parts would be, take that, change it to a plus, 1,718.5. So you calculate meridional parts and differences of meridional parts exactly in the same way that you do latitude. Same sign, subtract, different sign, add. All you really need to do is take your latitude, move it over to your table in Bowditch, and find the meridional parts. Remember, this is for latitude. You don't do this with difference of latitude. You don't care about the difference of latitude transferred into meridional parts. It's about actual true latitude values. That's critical for the next type of equation.